Welcome back. This is section 11.2. It's about scatter plots. Now scatter plots are a way of representing data using a graph and using some of those skills of plotting points that we've been talking about throughout the other two sections of this chapter. I'm going to start out with a problem. It says Mr. Sarah stacks dominoes and times his stacking. He wishes to make a graph of the results of the times and the dominoes stacked to make a scatter plot. So what I'm going to do here is I'm going to show that video of me stacking these dominoes, and I want you to see how many I stack, and we're going to plot the number of seconds, and then we're going to count the number of dominoes stacked. Here's how we're going to do it. We're going to do it in increments of 10. So it's going to go 10, 20, 30, 40, 50, and those are going to be our number of seconds. So let's watch a little bit of a clip of that video as we go through here. Alright, so how many dominoes did I have stacked after 10 seconds? Well, where I stopped the video, I had 5 dominoes stacked. Let's watch the next clip, the next 10 seconds, to see how many dominoes I have stacked after 20 seconds. Alright, how many dominoes did I have stacked after 20 seconds? After 20 seconds, I had 9 dominoes stacked. Let's watch the next little bit and see how many I had stacked after 30 seconds. How many did I have stacked after 30 seconds? After 30 seconds, I had 13 stacked. Let's watch the next little bit. Let's see after another 10 seconds if the pattern still keeps going. After 40 seconds, it seemed like I had this many stacked, 18. Let's watch the last 10 seconds and see how many I had stacked at the end. At the end, I had this many stacked, 22. If we were to make a scatter plot of this data, we need to label the axes and we need to put our data onto our graph. I happen to have a graph here, so let's see if we can line up our axes and label them appropriately for what we're going to do. Up the side, I'm going to put the number of dominoes stacked. So this is going to be dominoes and on the bottom here I am going to have seconds. So I'll label each of these. So this will start at 0, then I'll have 10, 20, 30, 40, 50, 60 seconds. And up the side, I need to go from about 5 to 22. So if I go 5, 10, 15, 20, 25, 5, 10, 15, 20, 25. Let's see if we can plot this. At 10 seconds, I was at 5 dominoes, and so I'm going to put a point here. What about at 20 seconds? At 20 seconds, I was at 9 dominoes, so just under 10. At 30 seconds, I was at 13 dominoes, so that's about here. At 40 seconds, I was at 18 dominoes, so that's here. And at 50 seconds, I was at 22 dominoes. You see how the scatter plot allows us to see a certain correlation. We can see how things go. As time goes on, the number of dominoes I was able to stack goes up. That's good for us. It also allows us to help predict what the next data is going to be. If I get to 60 seconds, how many dominoes should I have stacked? Well, it looks like I should have between 25 and 27 dominoes stacked. At the end, we'll see if I actually got to that 60-second mark and see how many dominoes I had stacked. We'll make a prediction. See if you can predict how many dominoes I had stacked at the end. When we're making scatter plots of data, it's much the same. And so when I take these two examples here, A and B, I need to remember that these charts represent ordered pairs. So my ordered pairs are going to be like this. -2, comma, -5. -1, comma, -4. 0, comma, -3. And 1, comma, -2. I took these straight from my chart. And so when I plot them in red, I'm going to use X's for them. If I label my axes, it's going to help me. So let me label these real quick. So this is going to be 1, 2, 3, 4, 5, etc. And this will be -1, -2, -3, -4, etc. This will be -1, -2, -3, -4. 1, 2, 3, 4. So you see how this goes. Now let's put these red X's onto our chart. If I go to -2, -5, I end up down here. -1, -4, 0, -3, and 1, -2. Notice my red X's are generally in kind of a line fashion. We're going to learn about how these correlations matter in just a minute. See if you can do the second one, and after the break, I'm going to show you how to do it. Alright, we're back. My ordered pairs are going to look something like this. 6, -6, and 9, comma, -8. If it helps you, you can go ahead and write out those ordered pairs each time until you get the hang of it. I'm going to plot these in a red and a green dot. So 0, -2. 3, -4, 6, 1, 2, 3, 4, 5, 6, -6, and 9, 5, 6, 7, 8, 9, -8, 1, 2, 3, 4, 5, 6, 7, 8. Notice there's a distinct difference between the red X's and the green dots. They have two different correlations. These mean something. And in our next part, we're going to explore what this means. We're going to interpret scatter plots. Interpreting scatter plots has to do with the way the data is arranged. So if you'll notice, these dots generally go in an up and to the right direction. They're not in a perfect line, but they go up and to the right. We're going to call up and to the right a positive correlation. Or a negative or a positive relationship. Since these go down and to the right, these are going to be a negative relationship. And you'll notice these are kind of all over the place. These have no relationship. So if they go up and to the right, they're a positive correlation or a positive relationship. If they go down and to the right, they're negative. And if they're scattered all over the place, they have no relationship at all. Let's interpret a scatter plot. First, we're going to make a scatter plot out of this data. Then we're going to interpret it. Unit cost. The table shows the cost per ounce Y of breakfast cereal when you buy X number of ounces. Make a scatter plot of the data, and we're going to predict what the cost per ounce for a 22-ounce box of cereal is going to be. So let's go ahead and label these axes. Here's going to be the number of ounces, and over here is going to be cost, and I need to label them. Let's take a look here. The number of ounces. I go from 9.6 to 25.5, so I'm just going to go from in increments of 5, 10, 15, 20, 25, 30. Notice I went in increments of 5, but I have that split in the middle that's going to be 2.5. And up the side here, this cost, I need to go from about 0.16 to 44 looks like my most expensive one. And so what I'm going to do is I'm going to go in increments of 0.6. So this will be 0.6, 0.12, 0.18. And as we continue to go up the side here, we get to 0.24 and 0.30, 0.36, and 0.42. As we plot these ordered pairs, remember it's okay to write them out. So I have 9.6 and 0.44. I've got 11.4 and 0.33. I've got 18.2 and 0.25. I've got 18.3 and 0.22. I have 24 and 0.17. And I have 25.5 and 0.16. Let's plot these. I'm going to use this red color. Actually, maybe I'll use green. A little bit of neon green never hurt anybody, huh? So 9.6 ounces. Well, 9.6 ounces is close to 10, and my cost is 44 cents. Well, that's up here off the chart. So this is 9.6 and 44. 11.4 and 33, so that comes up here. As we continue down, 18.2, so that's going to be somewhere in here. 18.2 and 0.25. 18.3, which is right next to it, is going to be 0.22. So that's down this way. 18.3 and 0.22. Then we get to 24, which is right before 25, and 0.17. 24 and 0.17. Hopefully you're following along with me. And 25.5 and 0.16, which is here. So in general, we notice that this data is kind of going down this way. What kind of relationship is that? Well, that's a negative relationship. And what does that mean for us? That means that as the ounces go up, the price goes down. That's good for us. That's where we get this bulk pricing. You buy a lot of cereal, you get it for a cheaper price. And so that's how we would plot something like that. Here's a couple of examples for you to do, and I've given you the graphs along with them. Go ahead and try to plot these, and if you need to, write out those ordered pairs and plot those on your graph. All right, guys, try these. We'll talk about them in class. We'll see you next time.